So in the previous video, we looked at the spawn method and the exec method from the child process module. These two methods help you create child processes asynchronously. They have their own set of pros and cons, and we have discussed in detail when to use which method. Now there are two more methods left that we'll discuss in this video. First one, which is called ExecFile, goes together with the exec method that we saw earlier. It's used to run executable files in a separate process, unlike exec, which used to run commands. So let me just import ExecFile from the child process module first. So I'm trying to execute the node command here with its version argument. So this should ideally give me the current version of NodeJS in my system. Arguments again need to be passed inside an array, just like we saw in case of the spawn method. And now if I run this, let me first just save this. Actually, it's called script. You can see that I get the version as expected. Now I mentioned that it runs executable files, so ideally I should be passing in the path to the file here. But it works fine though, even without the path. Now why is that? That's because the node executable file is present in my path variables. So a path variable specifies the directories in which executable programs are located on the machine that can be started without knowing and typing the whole path to the file. So even without typing the whole path, the operating system already knows that it needs to execute the node program because the path to the node executable file is already defined in my path variables. Again, pass in the original path where the node executable is present and it will work the same way. So this path right here is where I have installed my Node.js. So even if I try to run this, it's going to give me the same output. Let's say I want to run some other command, like for instance open up Google Chrome. In that case, I can again do the same thing. I can just replace the executable of Node with Google Chrome. Executing this script should now open Chrome on my system. So yeah, this works. In the case of Linux systems, normally bin and sbin directories will have the executables, at least by default. In case of Windows systems, program files or program files x86 directory is where the executables are stored by default. You can also run shell scripts on a Linux system using ExecFile if you want to. ExecFile, unlike exec, won't run your commands inside a shell. Instead, it spawns the executable file as a new child process, making it slightly more efficient than exec. If you have problems running ExecFile on, say, Windows systems, you can use the shell option just like we did in case of the spawn method in the previous video. So this also has an options section wherein you can pass in certain configurations if you want to. So if you want to pass the shell option like we did in case of the spawn method, you can do that for ExecFile as well. So yeah, the next method and the final method that we'll look into is the fork method. This fork method, just like any of the previous methods, spawns a new Node.js process, but this time it also invokes a module that creates an IPC channel between the child and the parent process. IPC stands for inter-process communication. It's basically a set of mechanisms an operating system provides to allow processes to manage shared data. You don't really need to worry about IPC for now. All you need to know is that it's going to open up a channel between the child and the parent process so that they could send messages to each other during a certain event. So anytime a certain event occurs, a child can send a message to a parent or a parent can send message to a child. So this to and fro communication can happen between the two processes when you create the child process using the fork method. This method will take the URL of a file as its first parameter. So the child process logic will now reside inside that file. Let me first import the fork method here. And I don't need this, so I'll just remove ExecFile for now. And I'll create a child variable, which is going to hold the instance of the child process that we create. So yeah, inside this child.js file, we'll have the logic for our child process. So I need to create this file first. Inside the directory, I'm just going to create one file, child.js. Now inside this child.js file, we'll simply add a console log statement for now. So console.log child process. Now if I try to run the script again, this script right here, I should get the child process console log statement right away. This basically means that the code inside the child process file gets executed the moment we create a fork in our parent process. This is a crucial point, and I'll come back to this later. You can also pass a second argument to this method, which is an array of strings as arguments of the child process. Inside the child process, you can access it just like you normally would in case of any other process by using the argv, the arguments property. So if I want to pass in, let's say, a few arguments like hello 1 or whatever, like Jumanji, I can then access this inside my child process file using the process.argv property. If I clear this and run it again, you can see the arguments that I get from the argv property. The first two arguments are static. It's going to be the NodeJS executable and the path to the child process. The rest of the arguments are the ones that we passed in the script file inside the fork method. The third argument is a set of options that you can pass to your forked process. We don't need to worry about these options for this example, so we'll skip it for now, but you can read about it later. Only the first argument is mandatory. Rest everything is optional. So yeah, I'll get rid of this argument as well for now. Don't need this. Okay, so now we have a forked child process. So let's try to send a message to this process. We can do that using the send method. So below the line, I'll just use the send method, which should ideally send a message to the fork process. So child.send is going to have a message. It says hello child from parent. So now, since I'm sending a message to the child process also needs to know if there's any new messages from the parent. Since all child processes or all processes in general implement the event emitter API, they can listen for events. That is also the reason why we are able to send events from the parent to the child process like we did over here. So let's listen to the message event as well. I'll just remove this, and below this line I can use the process.on method, which is going to listen for a message event, and inside this I'll have a callback function which has the message as the argument, and I can just console log it over here, message from parent msg. Okay. Now if I run this, let me clear this first. You can see the child process console log statement, which is line number 1, and the second statement and the second console log statement is the message from the parent process. The send method that we executed over here gets listened on this line number 3, and it console logs the statement. Now if you notice one thing, you'll see that the process has not yet ended. It's still listening for any events, which means that it's still running. You can manually exit by using the exec method with an exit code. There are various exit codes out there which mean different things. For instance, code 0 means that there are no more async operations left to execute. It's also the default code if you don't pass in anything. You can read about different exit codes later. Now in the parent process, you can also listen to the close event of the forked process. So to exit from the child process, I'll just use the exit method with the exit code. I'll restart this and this time you'll see that it's going to exit from the child process. Yeah, so it console logged the first statement, the second statement, and now it's exited out of the child process. And the parent process, you can also listen to the close event of the forked process. So once the exit happens from this child process, I can listen to that event in the parent process. So to do that, I can use the close event, which is again going to take a callback function with the code, the exit code that I just mentioned. And inside this function, I can do whatever action I want once the process closes. So for now, we'll just console log child process exited with code. If I run this again, you can see the console log statement here. So you can run some functionality if you want to whenever a child process exits using this close event handler. Now if you want to send a message from the child to the parent, as you might have already guessed, you need to use the same send method, and this time instead of the child being the listener, the parent needs to be the one listening for messages. So we can use the same message event listener on the parent process. So yeah, let me just comment these two for now and comment this over here. This time I'm going to send the message back to the parent. So I'll use the send method again with a message of my own saying that child message to parent. Inside the script, I'll listen for any messages using the same message event. There's going to be a callback with the message, and I'll just log the message. Let me save this. If I run this now, you'll see the child process console log statement, then the message from child, which is what you see from this line here. So it's the same thing. You can send messages from the parent to the child or the child to the parent. The process is very similar. So now that you know how this works, let's take a look at a more practical example. Say we have a piece of blocking code in our file. This is a simple HTTP server that takes in a request. If the request URL endpoint is heavy, then it's going to do the heavy computation, as you can see over here. This heavy computation is nothing but a typical while loop, which is going to iterate this many times. It's basically going to take a while before you get the output. So it's basically going to occupy the call stack and block the event loop until and unless it's not finished. The other API endpoint is the light endpoint, which is going to return the response right away. So yeah, I'll just clear this and open up two more terminals. This first terminal is the one which is going to run the node server. Second and the third terminals will each be used to make a request to this server. So let me start the server first. Yeah, so it's running on port number 3000. So now to make a request, I need to use the invoke REST method for Windows. I don't have a curl installed on the system, so I need to use this. So this terminal is going to make the light invocations. I'll use the second terminal to make the heavy invocations. Or instead I'll switch both of these. Yeah, so when I make the request, when I make the heavy request and the light request at the same time, you'll see that only after the heavy request is done will the light request be executed. So now I'll run both of these together. Both of them are waiting for now, and after a while, once the heavy request is done, you'll see the light request as well. Yeah, so now that the heavy request is complete, you can see its output first. the light request output came after the heavy request, so this basically means that the heavy request blocked the event loop. And the order of requests you can see over here. The first request was the heavy one, the second was the light one. So this clearly is a problem. This is going to block the event loop, and any request that you make when this heavy request is being executed is going to wait. So this is not a good thing. This is going to be a problem. Now to solve this, we'll bring in the fork method. So we'll use the same child file that we used for the previous example. What I'll do is I'll simply copy the block which takes time and put it inside the child process file. So I'll copy this inside the child process. I'll uncomment this first. I don't need the send message. And inside here, I'll just paste the blocking code. Now, once it is done, I need to send the message back. The process.send, and I'll just print the total number of times the iterations happened, so the total count. I can say this now. In the parent file, I need to first create a child process. After this, we can send a message to the child signaling that it needs to start the heavy operation, and at the end we listen for any message that we get once the operation is done on the child process's end. So I first need to get the child process. I'll use the fork method, and inside here it's going to take the path of the child process. Now to start the child process, I'll first send one message, because otherwise it's not going to start this block, because only until it gets a message from the parent will it start this process. So I need to start it first, and at the very end I'll listen for any messages. So this is only going to get triggered once the while loop is done, because only after the while loop I'll be sending the message. So this message is going to take in a callback function, and I'll just send back the message as a response. I don't need these. Okay, so now I'll save this. Let me clear these. Let me restart the server. Yeah, so this is done. Now if you try to make a request to the heavy endpoint and the light endpoint at the same time, you'll see that it's not blocking anymore. It makes the light request even though the heavy request is running in the background. Actually, I need to add one more message here so that we can differentiate between the requests. So heavy request. Yeah, so now let me restart the server and get the heavy and the light request. Now if I run both of them together, you can see the heavy request executed first, the light request executed the second time, and the light request is already done. It didn't wait for the heavy request, even though the heavy request response has not yet, it just got executed, so the response came in after a while, but the light request was already done first. So this basically means that it's not blocking the call stack. It let the other request, which in this case was the light request, execute asynchronously side by side. So it's not blocking the call stack this time. So this is how fork method handles multitasking. It basically offloads any other processes which are heavy to a different subprocess, and it lets other requests or other processes execute while this heavy process is happening in the background. And yeah, I believe that is enough information regarding these 4 methods. There's obviously plenty more that you can find about these methods, but I believe these 2 videos should give you a brief idea of how things work and how you can implement them in your project. We'll also be taking a look at clusters and worker threads in the future videos, so do subscribe for that. If you have any doubts or suggestions, you can put them in the comments and I'll see you in the next one.